Welcome all of you to our September version of the Tech Talk AI in engineering, a new topic, a new insight into a distinct in a discipline. The subtitle of our conversation today is going to be, will it lead to a paradigm shift in engineering? I'm really excited about this question, about the topic combination, and I think we have 4 very great speakers to talk about it. So on behalf of the entire KI-Pack team, once again, welcome all of you. My name is Mark Harahan. I'm a venture development lead at KI-Pack. I'm responsible for all the startup activities, but also our program offering at the intersection between startups, corporates, and whatever are part of our network. And yeah, for all of you who are first-time visitors of a KI-Pack event, I would like to just give you very shortly some information about KI-Pack and what we are. So we are KI-Pack, and KI-Pack, the slide should come up in a second. We at KI-Pack are an NGO based in Berlin, but operating Europe-wide. We have been founded in 2021, so approximately 2 years ago, with 12 industry champions, universities that you can see on the top, on the bottom left page, part of the page. And yeah, within that 2 years, we've now all grown to already 114 members. You'll probably recognize some of the logos. We have corporates being part of our network. We have also a lot of startups and scale-ups. We have research organizations. We have other NGOs being part of that. And we consider ourselves, and we are, a diverse ecosystem. We have different perspectives in that. We have different industries being part of it. We have different maturity levels. We have different areas of expertise within this network. But what it unites all of them is a deep passion for AI. It's a very interesting topic, very deep. We also focus on quantum and related technologies, for instance, like robotics. It's also part of us. So it's not only AI, but that's the main core, I would say. As I said, we are Berlin-based, but our members are operating Europe, worldwide. Some of them are based already in, for instance, Sweden or Norway, but we have others being split over all of Germany. So a diverse ecosystem that is interconnected and unites under the AI umbrella. And what do we do at KI-Pack? Well, from the pictures you can already see, well, I would say there's a lot of things we're doing, but 5 main takeaways, I would say. The first one is bringing together people and enabling good connections between them. You will recognize in our networking events that we do that people are meeting up and exchanging ideas. Then second, we are enabling joint projects within our members. There are, for instance, public funding projects we are doing. There are programs that we are designing for enabling our members to work together and to build the next AI innovation. Then third, we are promoting awareness and visibility. We talk a lot about AI. For instance, this Tech Talk today is going again one other topic and one other perspective of AI in a certain discipline. We are very loud on LinkedIn, and for instance, on our newsletter as well. So we are sharing, and we are trying to speak about it and promote the technology and advantages that it has. Then fourth, of course, we are sharing news about the AI ecosystem. We are sharing market insights that we are having, and of course, a lot of other opportunities that are going to reach us. You will hear about awards, you will hear about conferences that we are promoting and taking part of, sometimes white papers. So it's about, being on track about latest news. And then lastly, of course, we are also working on our infrastructure offering. We have cute little space, our KI-Pack office in Berlin, Mariendorf, and we are expanding as well. But more about that after the Tech Talk. So if you haven't heard about KI-Pack, this is a good moment. Check out our website. You can also shoot me a message on LinkedIn and just connect. I'm very open and happy to discuss with you any questions you might want to have. So, and that being said, I don't want to waste too much time to share some latest information before we start. So this Tech Talk is going to be recorded. Your camera is not switched on or so. So that shouldn't be an issue. If you have any questions, please write them in the text box. There's going to be a little Q&A that we are having after that tech talk. So your questions will be asked. You can also write these messages while the tech talk's going on. And then at the very end, we will just go through the questions. So whenever there's something you like a bit more focus on, or you want to know some more things about, then yeah, really welcome, use the chat box as well. And yeah, the session will be uploaded after the tech talk. It takes approximately 1 week to our YouTube channel, so you can rewatch it if there are some interesting passages you like to listen to again. And yeah, I think that should be it. Information to start. We have a very interesting topic. I already said it. It's will it lead to a paradigm shift in engineering? And we have 4 speakers today. We have Astrid, we have Benham, we have Omar, we have Matthias. Who I would like to pass over the word today to introduce themselves and yeah, share something about their background and then kick off the conversation. Matthias, I'm handing over to you and closing that yeah, presentation right now.
Thank you very much, Mark. I'm sorry, it doesn't echo. Is a mic open maybe?
I think it was Mark, so maybe it should now be fine. Try again.
Okay. Thank you very much. Okay, thank you very much, Mark, for the intro. Thank you very much to the whole KI Park team for organizing this event. I'm super excited to have this discussion today. Maybe to share a background why we picked this topic for the talk. I was visiting the KI Park summer event, and it was great. It was an exhibition and a lot of interesting presentations, and of course a barbecue. But the one thing that I've noted there was that I think of the, let's say, 80 people that presented there and that had shows there and that I talked to, there was virtually nothing about artificial intelligence used in engineering applications. So in actual engineering industry applications, NAVASTO was more or less the only company. And so we decided to, well, shed some light on how artificial intelligence can be applied to the engineering process in general. And I'm super happy that we have 3 companies represented by experts in this talk that cover different aspects of AI in engineering. So there's Siemens Energy, who are building a physical product and use AI as they might have used in the past simulation as a means to an end. There is 1000 Kelvin that built a product where AI is integral to the product. So without the use of deep learning, machine learning, they could not offer the product. And there is NAVASTO, where our business case is really to have a general purpose, a machine learning and deep learning platform. So as a simulation framework was a general purpose tool in the past, machine learning and deep learning is now a general purpose tool for us. That's an offering. And one sentence about my own person. So I'm Matthias. I'm an engineer by education, an aerodynamicist, my PhD here in Berlin, before co-founding NAVASTO. And for the past almost a decade, we are now industrializing machine learning and deep learning for industry application. I would like to lead over to Astrid.
Yeah, thanks, Matthias. So yeah, then just a little bit about myself, and I think actually what Matthias just described with this event, and then really seeing not a lot of use cases or examples where AI is really used in engineering. I think this really resonates quite well also with what I would describe as my mission and passion, really to bring AI and data science into engineering and really to see how we as engineers can really take advantage of these new technologies. And yeah, so my background is also in mechanical engineering with a PhD in numerical methods. So I would say just for me personally, coding and the data side of things has always been a part of my work. But then yeah, almost like 5 years ago, I really decided to make it even stronger and really move into the hop on the data science train. And so most of my professional experience I have in gas turbine engineering. But I also worked for different corporates, startups, and was also running my own business, also exactly in this interfacing area between data science and engineering. And now I'm happy to be here and represent also Siemens Energy's view on this topic. So I would then hand over to Omar.
Good morning, everyone. Thank you for the kind invitation. I'm really excited to share the stage with the true believers, if I may say. My name is Omar. I'm the CEO and co-founder of 1000 Kelvin. And as Matthias said, we are a company that leverages machine learning algorithms and generates a product that goes deeply into the manufacturing industry. So we are extremely focused on enhancing 3D printing using AI, and we focus on this vertical. As of my background, I actually come from an engineering background, PhD in mechanical engineering, with actually a specificity that I worked for Siemens simulation division as director of technology there. So I had to do the shift from physics-based simulation to AI, but we're going to talk about that today. Thank you.
Cool. So I think one of the interesting questions is, what do we mean with this title? What's the paradigm shift that we are talking about? The question was like, will it happen? I think it is actually happening at the moment. And at least when we thought about this title, or when I thought about this title, the idea was that it's going away from this paradigm of iterations. As an engineer, I think I'm allowed to say that engineering work is trial and error, meaning that you have an idea and you design something digitally or physically, and then at the end of the day, you need to see if it's working. And if it's not working in the first instance, then you'll have to do a redesign. And to know if it's working or not, we conventionally did some experiments. And then for the last 20 years, we added to this simulation. So we didn't have to build a physical prototype and test it in a lab, which took probably a month in the case of something like a vehicle, but we could run a simulation. But this simulation still takes days, at least hours, to come back. So the iterative process is always paused when you have to wait for the simulation result to come back, when you have to wait until your answer comes back to the question, is my product working or not? And I think there is where machine learning and deep learning come into play, because they're real-time capable. If a machine learning model is trained well, it can produce more or less the same results as a simulation or an experiment would produce, but the answer comes back in seconds or milliseconds, even depending on the size of the model. And I think this is the interesting part about where we can use machine learning and deep learning in engineering processes. This is the paradigm shift that at least I had in mind when I saw this title.
Yeah, and I mean, maybe I can just add on to this, because then also, as I already said, my background is of course also in or not of course, but my background is in simulation. So I'm of course also seeing this this use case as the most, it's just the most present for me. And I actually feel the same way as Matthias when it comes to this paradigm shift, because I just feel that AI and machine learning in this area of application is now at in a state and a place where simulation probably was like 30 years ago. And so I feel that this might be now the new technology, which will become like the new simulation. And we cannot forget that the same or a similar paradigm shift, which went from experiment to simulation, also took place. It took some time, and it did not make the other technologies vanish, but it really just changed the amount of simulations and experiments. It just made it more accessible for a lot more people and actually a lot more cases. And I feel that this is a similar development what we will see now in the future.
If I can add, well, first I can only echo what you guys have said. I think if we take a step back, and we think about really what is this technology solving as a problem for the industry, it is quite clear. Competition is extremely hot between European companies, American companies, Chinese companies, and the game changer here is the time to market. How can you bring product faster, better? And I think that's where this technology is going to be a game changer. Let me elaborate on how we do that in 1000 Kelvin. Today, as you said, Matthias, a lot of engineers try to make complex components using 3D printing, and they will try and end up trying many times, failing, changing the orientations, and that costs time, energy, resources, and ultimately makes them unsuccessful. Then there was the evolution of moving to simulation, as Astrid mentioned, using finite element simulation to simulate these components, see how they will distort, fail. But unfortunately, this was not extremely successful. Simulation still took a lot of time and could not provide solution that these users could implement. And this is where the 10x improvement comes with machine learning technology. Not only you can go and simulate more complex things faster, you're also able to use these machine learning technologies to build optimization. And I think having this a closed circle is where our customers, the people we work with at the end, see the massive competitive advantage, and they can go and implement in the reduced time to market. So in essence, I think we are agreeing here that reduction of innovation cycles, faster time to market is why we are excited about this machine learning technology. This is the killing competitive advantage from my perspective.
Maybe now just to lead this over, because now we have discussed a lot about what we do see as let's say as a successful development of this new technology and what it can actually bring in terms of advantages. But maybe now we can also discuss a little bit what are actually the requirements to make this really successful. And this also then resembles a bit to expectation management, because it's on the one hand side what these new technologies promise to do, but there are actually also high requirements. So I think especially now when we talk about these new technologies and the use case to make some simulations, to replace simulations for some use cases. So I don't know, maybe Matthias, you can tell a little bit what are actually then the requirements to make this successful.
Yeah, with pleasure. So I think obviously, since we are all using data-driven methods, it's very important to keep in mind that you need high quality data and enough of that. Enough of that is a lot of people have the impression that it requires like tens of thousands of data sets or even millions of data sets, as we know from large language models. In an engineering example, this could be much less, like dozens or maybe a few hundreds of samples. But at the end of the day, you need high quality data, evenly distributed in your design space, so that you can actually train a model on. Because at the end of the day, it's what we're doing. We're building an interpolation model or a regression model from an input, like a geometry or a set of parameters, to a desired output, like a flow field or a scalar value, like a performance coefficient or something like that. So data is the one thing that I see is necessary. And the other thing that I encounter very often when talking to potential customers is that there still needs to be a lot of education within large companies. Almost everyone has a large team of CFD engineers or FEA engineers available, but very, very few people already have sufficient machine learning and data scientists at the end of the day within their ranks to immediately use this technology on their own. This is what I at least see. So there is some kind of cultural change that's involved in the thing. What you take from the industry point of view, where you're actually working within such large companies?
Yes, that's right. Hello, Jesper. Sorry, I'm a little bit late, but yeah, in our experience here at Siemens Energy, we also need this cultural change. So we have hundreds of simulation engineers, but the switch to AI or to use machine learning and optimization is going piece by piece, and we should not overpromise here anything. So the first time we introduced AI, the expectation was it comes and then it replaces all simulations. That's not true. So we need for every topology, for every variation simulation, we need verification simulations. So in the end, still 80% of our people are still doing simulations, and some of them help with machine learning to augment, to improve optimization, to get a little bit faster to a solution and a little bit faster to robust design. But AI is not like a complete replacement or some miracle which reduces our simulation time by 90%. I would even say the trend of number of CPU hours for simulation goes up, and it will still go up and up and up for the next 10 years. And maybe then machine learning could replace some stuff. But for now, we have new applications. We use, for example, hydrogen instead of gas. We need new data. So it's all simulation is required. New types of geometries with 3D printing. So again, and this is all stuff which we don't know. We don't have data, and we have to build piece by piece.
And I think also very important when we talk about this cultural change, it's that so the first thing is really everyone needs to be aware of the value of the data they are generating in their day-to-day jobs. So I think really I think a very typical situation for every simulation engineer is at some point like your hard disk is full, and then you would start to in a panic mode delete stuff like randomly because you have to. And so we really need to overcome this kind of situation. So data is valuable, and everyone needs to be aware of this. And also, data needs to be stored and sorted and really curated to make it usable for the future in future use cases. So that's the one thing. The other thing, from my perspective, is also, and I don't want to say anything against any one of us, but I already feel that probably also the four of us, we are already not like digital native. But then we also have a lot of colleagues who are even farther away from being digital native, and it's really about also still enabling also these people to take advantage of new technologies, making it accessible also for them, talking to them, and really making sure that no one is scared, but rather excited about these new technologies and new opportunities which this brings. And there it's really about, okay, so how can we bring these new technologies also closer to everyone and make it usable also without forcing people to take, I don't know, coding courses for how many weeks. So that's also a real important task for companies.
Exactly, yes. So you really should observe your users and see where they spend time and where they really do repeatedly work which they don't like, and then there you can support with AI, with automation, and so on. But
I think it's ultimately use case dependent. You cannot make a generalization based on one industry or one segment. Or obviously, when you're designing end components that require a lot of precision and physics simulations, you can accelerate things. But there are also use cases where the technology is robust and light enough for people to use it. I think when we think in the retrospective few years ago, no one would even talk about this, and here we are today, already talking about use cases where we accelerate. And I'm just trying to think about the future and how we push in together, we could enable many use cases that were not possible before. So the way I see it in the manufacturing industry, the way we use it, I see massive opportunity for manufacturing, very, very low-hanging fruit use cases where you can go and solve complex problems. Yet, what I have to agree with you is if one of the decisions we have made at 1000 Kelvin is we will not give people technology. We will build a model ourselves, and we will build our products on the top of it, and we will just give them the functionality. So that's all that work for the customer to build their model, to become physicists, to become precise about what they do, they don't have to do it. So I think there will be a lot of new category of products coming soon where you know, AI will be just an enabler. You will not even talk about it. It will be inside and that's it. So when our customers are using our tool, they don't even know if it's AI. They just get a tool path for a machine, and we don't even need to talk to them about, did we use AI? Yet it is enabled by AI. So I think those are the exciting hidden use cases that I see coming more and more in the future.
Yeah, that's very good if you really can encapsulate it into a no-code representation. Some engineers are afraid if they see Python code. So if you have no-code solutions and surrogates and so on, which really help them in their use case, that's what we also see in Siemens Energy. You get a much higher acceptance.
Yeah, I think it's a two-level problem, right? I mean, there is on the one hand side the expert task of building models and defining correct architectures for the neural networks eventually. And on the other side, it's the using of the model. Whatever you do with it, that the benefits of exploiting the real capability of the model must obviously be very much user-friendly without coding. But it doesn't mean that there cannot be an expert aspect to this whole thing, in my opinion at least, because at the end of the day, you also need experts that write code to solve Navier-Stokes equations, but the end user then has something that's conveniently used. And maybe to touch back to the question, what can AI do? Do we need simulations? Is it going to replace simulation? I don't think it's going to replace simulations in the near future. Probably never. And I completely agree. What we are seeing with our customers is they are simulating more. But what we also do see is there is a decoupling of problem solving and simulations. So there's a left shifting of simulations. A lot of simulations can be run in parallel before actual human beings interact with solving a problem. And the engineers then actually work with the machine learning model or a deep learning model to iterate quickly, while in the background, simulations are run to improve the model or to compute the model in the first place.
Yeah, and I actually also want to respond a little bit to what Omar also said with these hidden use cases. And yeah, I think that's like the optimal case when it works like this. But then for me, as already said, with the simulation background, I always also compare this a little bit to a simulation software. And now if I would start using something else which is more AI driven, then I also actually do see the task that the expert task, which usually would be to double check the produced result and the simulation results and just do, let's say, like a visual check and to see is it valid or not. So this is something what has been trained for many years, and you're just able to check this. And this is something where we need to really develop this ability to do a similar task, but for something AI driven. And there we just also need to train ourselves, because this has to be a different way of checking and validating these kind of predictions. Because just as an example, if a flow solver is not able to solve a very, very simple problem, I don't know, flow through a pipe, then it would never be a successful tool. But we cannot use the same quality criteria on something which is then AI driven in this area of application, because this would just simply not work. If the model whatsoever has never seen something similar, then it would not be able to predict it. So there we really we need to find other criteria and KPIs for checking the confidence of the model. And this also then brings some new, let's say, expert training with it.
I mean, from our perspective, I think what you just described is absolutely correct and super important to remember that we need to get used to the tools, just like we got used to CFD, and over the time, I think we're gonna, or a lot of people gonna realize what's working and what's not working, and we are not there at the moment. But as you're very well aware, there are methods like Bayesian layers in a neural network that are able to predict some kind of uncertainty of on top of an average value or something like that. And at NAVASTO, we have spent a lot of time on making that work and seeing how we can transport information by applying something like variational nets to our architecture. And at the end of the day, what we have nevertheless found is that all those statistics within the prediction are not necessarily what the end user wants to see. Instead, what we're now doing is we kind of checking the new input compared to the training data. And by comparing the closeness of something that's new, a new geometry or whatever, with what was part of the training data, we simply produce some kind of a go or no go for an engineer who does not have to be an expert, and tell him if this is something where the model is probably trustworthy or where they have to run a simulation. So I think those are the methods and the workarounds that we at the moment have to go to have this tool set actually productive for non-experts.
Exactly, and then I think also a new field comes with this hybrid models. So a lot of our predictions are not very precise in some regions, and we have measurements data, and we cannot recreate them with CFD or FEA. So there are models like hybrid models where we fix our simulations. So we make a delta between reality and simulation directly applied, and to get this as a value for the designers. But this also must be done automatically with known data, and this is the hardest path to match the data, align it, and all the measurement data is always not very clean, so you have to do a lot of data cleaning before you use them. But this is also, I think, a new field where we can get trust is that machine learning helps the simulation engineer to get the real answer back. And then piece by piece, make it faster, and then replace the 3D simulation with a 2D surrogate model and give him the opportunity to test some new topologies based on the knowledge we have. And I think the same thing happened in the 80s and in the 90s, where people developed like the semi-empirical correlations for flows through a cooling and turbine, or all this semi-empirical correlation for compressor, turbine, for all the CFD applications. They're just near to a measured solution, and they fixed it, they put new equations into it, made them longer and longer, and they were really used for 10, 20 years until we had 3D CFD. And in the same aspect, I think CFD and AI will go piece by piece. They will be introduced and then they get bigger and bigger.
Yeah, I just taking this on with the hybrid models. I really feel that that this is one of the biggest opportunities also of these new methods and models when they are able to actually process all kinds of legacy data and really combine these different data sources from experiments and from simulation. We could even think this further and say, okay, why bother about the simulation results? Let's just build a model which is based on the really high precision, high fidelity experimental measurements, and then this would actually even give us a model which is probably even better than any simulation tool. So I really think I mean the limits we are probably giving to ourselves, or I mean in the end, we do decide what we can put inside the model, and this is then the best what we can get out of it. But yeah, if we really think about enabling all the data, what we already have, bringing this inside, and then combining high fidelity data, also with other data sources, I think there's a huge opportunity there.
I think it's kind of a way of store knowledge. AI models are not just a tool to make quick predictions based on CFD or experiment or both or whatever, but it's also a way of, I mean, if I think about Siemens Energy, they were literally sitting across the street from my office here. I don't know how many people work at Siemens Energy, but I guess thousands of them. So it's very difficult to, I assume, to have the information that's available within this company accessible, at least based on there is a simulation for something similar somewhere in the storage. How many people know that the simulation even exists that was done? So I really think AI can be also a container for making knowledge accessible instead of going through the database, opening something, and so on. So I think there are a lot of aspects where this technology can be useful way beyond just being quick CFD.
I think on the use cases, I'm going to be more defender of the low-hanging, easy use case, because I feel here, since you guys are in the high-end kind of application and automotive and gas turbines, those are extremely complex, application to design and engineer. Now think about, I'm just thinking simple here. Think about the last release of SimScale, for example, a cloud-based technology. It's not approaching customers like yours, those who never use simulation. And like a lot of engineers worldwide could be using simulation, then they are not. And I think that really making it simple and easy to use just by making predictions fast, give you a first impression, massive. This will unlock better engineering, lightweight applications. And I think we should be fair to this technology and its maturity and its impact at different levels. Of course, it's going to be hard to find its place in high-end engineering applications. But perhaps when we look at the full landscape, there are so many applications that are already benefiting. So I think the way I look at it today, not to, just to be fair to the state of the industry, is that there is adoption already by companies like Siemens. So we're not discussing imaginary thing. I assume, Astrid, you're already working on that, guys. And I always have my customers already using it without even knowing. And I see releases from SimScale, in partnership with NAVASTO, by the way, where they're already releasing this to thousands and thousands of engineers worldwide. So I think this is a technology that is absolutely worth studying and looking at from every engineers and every engineering application. And from my view, I'm actually wondering what's your opinion on, we talked about it at the beginning, the acceptance rate or adoption rate or friction or whatever you want to talk about it, because I think that's where we as early users, leaders need to send the message that actually this is not replacing people's job. Someone just in this discussion just said it. We are doing more simulation. God, the engineers are becoming even more important. A precise model, validating the model, more simulations, more data is going to be generated. So I think this is exciting time for engineering community.
Yeah, I totally agree, and that's exactly really what we need to do. There is a need for a lot of communication, and really ensuring that people are not scared but rather excited, because for each and everyone it brings just a lot of opportunities. I think it's probably what I do foresee with this is really also just a huge time saving. So hopefully I won't be needed to do any kind of boring repetitive tasks, and that also these AI methods in engineering will then bring the same advantage as, for example, ChatGPT saves me a lot of time when I need to write a nice text. And we really need to bring this excitement and this idea of this being a chance to each and everyone out there. Yeah, I fully agree.
Yeah, but it's also true that it takes some jobs away. So it's also true that for some people, the importance in the design gets lower. So if you have a multidisciplinary process chain like we have, so before we had the aerodynamic engineer, he did the aero, the thermal engineer who did the thermal, the mechanical. Now we have some genetic algorithms, some search algorithms supported with machine learning who are doing all these disciplines in a row. So the aero discipline guy really told us he doesn't feel respected because he's just delivering the tool and to make the aerodynamic calculation. But an algorithm makes all the decision. And 10 years ago, all the designers did some decisions how to really design. So on some aspects, some people will lose their decision making. So it will go to an MBO driver, and the driver will design the part, the multidisciplinary part, and some people will just support with simulation, do verification calculation, do the product definition part. And this is new in this company. So I can feel some people who really left our, for example, aerodynamic department because they wanted to have more discipline.
But I have to disagree a bit. Yeah, please, Omar, go ahead.
Okay, I just want to mention a point because I was visiting a customer last week where we deployed our technology, and we had the meeting with the management at the beginning, and they see the business case and the value. And one of the comments that the management told me is like, "Oh, I'm going to free the time of my engineers. Please don't forget. We should not forget that we have a crisis of engineering talent in the West. It's not like we have engineers available everywhere. A lot of companies are looking for engineers, are struggling." Now, the afternoon of the meeting, I met with the application engineer, and he looked at me in the eye and he said, "If your technology is successful, I'm the first to lose my job." Which I agree with your statement, because he was honest, and it was not like a laughing, joking situation. He will not be needed to do his work. So yes, we should not lie to ourselves. A lot of people doing these tasks will become obsolete, period. However, when you look at the global economics, I think I feel like we are lacking engineers everywhere. And it's very hard to scale the amount of talent in engineering. So bringing people is a big opportunity. And I'm talking here as a CEO of a company looking for engineers. It will be a fantastic opportunity to have more talent. Because we have a lot of problems.
I also think it really depends on the use case. I mean, for like something like a gas turbine, where no designer, no stylist is involved, for example, you can probably actually formulate multi-dimensional optimization problem, but there are a lot of jobs out there, a lot of products out there that are either even more complex, so that you cannot simply define the optimization problem, or where it's simply not that clear where the true optimum is. Especially when something like style is involved, like in the automotive industry, where most of our customers are from. Usually neither the structure people nor the aerodynamicists decide how this thing looks at the end. The stylist is the person that makes the last call on the overall shape. And this is something where machine learning can help people to iterate quickly and therefore build a better product, but you still need a human being to judge if it's working or not working, if it's actually feasible, if they can sell it to the style department.
And I actually also would just like to mention that I always see that it rather takes a burden away from people to doing repetitive, boring stuff. And I mean, in the end, this will just allow altogether higher speed. Design cycle speed, so everything will probably speed up a bit. You will still need the people to set up and their expertise, because the real ultimate decision making, this will still be done, of course, by humans. So I always see these AI tools more as, let's say, personal assistants who are there to help me doing my job better or faster and perform better, but the decision will still be made by humans. So I would rather see this as an opportunity which will free up some time. Takes away burden from the people.
Yeah, but they don't have so many decision making might or in aerodynamic, for example, we are doing a lot of this algorithmic optimization and so on. And the tool decides the basic shape, and they do a little bit polishing in the end. But it's not like in the past, in the last 20 years, where they did the designs on all sections by hand and so on. So decision making is getting a little bit less and less and less. They are doing more the verification calculations and so on. And it's also multidisciplinary decision making, which is even more complex because now the aerodynamic is maybe priority 3 because we have to do tuning, lifing, other disciplines first based on the use case. And this can change. And we should not also underestimate people. Some people really like repetitive tasks. They love it. And if we take it away from them, they will try to refuse it. So we have to think about like getting them tools to get new stuff done, new, much better designs done with the task which we replace with them. So that's the problem. It's not like here's the tool, here's the AI, you are replaced, just do the verification calculation. That will not work. Then they will refuse it, and then we have to find other ways. We have to say, okay, this is a new tool, and this is a very challenging task, getting even more efficient with higher temperature, getting new materials, which is more challenging, and so on. And then really see how we can really challenge the engineers.
All right.
Just on that one, I think
Yes.
one of the points is the governance. I think what you're referring to is at the end of the day, what's the philosophy of how the company wants to use AI, and I think that those are really important that I think are more and more on the boards nowadays. Thank you.
Yeah. The question is when is AI ready to really also make some other design decisions, not only like algorithmic shape optimization, but really setup optimization and run stuff. This will get really
make me a gas turbine. Huh?
Yeah.
We're all converging to become prompt engineers anyway, sooner or later.
Yeah. Our chief of engineering said he wants an Excel table where he types in megawatt and clicks enter. The rest should be done automatically.
I think actually this probably leads already to some of the questions
Yes.
which we could see in the meeting chat, because I mean there now we are like looking into, okay, so like what's next, where are we heading with this? So when we think about generative AI, cool diffusion models, and so can we also do something like this, like a text to design? Okay, give me a gas turbine with a 600 megawatt, boom, and then the design pops up. Because we also had a question in the meeting chat if anyone uses generative AI to produce synthetic data to train surrogate models. I think it's this probably cannot be answered with a general yes or no, but in portions for sure, because there, for example, what can be done is to use some generative AI to generate then, for example, new geometries. And then these new geometries can then still be processed and with the usual simulation process chains, for example. So you would generate then the data fields with legacy tools, but with a new geometry generated by this generative AI, and then this data altogether could then be used again to train a surrogate model with this. So these are just my 2 cents about this question.
I think I always wonder when people say synthetic data, what does that mean? It's a physics-based data that costs millions of dollars to run on HPC and solvers and a lot of engineers behind. And we have built all the engineering world around us, buildings, planes, cars, trains, using this simulation. So I think we gotta respect this data a bit more and the people behind it, and call it physics data, validated physics data.
I think generative AI is useful to run something like adaptive sampling. If you have a problem that's easy enough to actually produce with generative AI a geometry that can be then run through a standard CX process, then you can probably use generative AI to produce additional data. And with Omar, I wouldn't call it synthetic data if it's from a simulation. For me, synthetic data would be to use the data that's coming out of a neural network, for example. And I think this is very dangerous to produce data with the model that you're trying to train. There are a lot of studies currently out there where they look at how LLMs degenerate when they are trained with too much of artificially generated data. So it's all gonna converge towards something like an average value naturally. So I'm not a big fan of using synthetic data, rather maybe augmenting data if there's not enough, but not really generating data with AI to then train AI on that. Don't think that's a sensible way to go.
You mean that Facebook is training their model with OpenAI data?
Yeah, and the other way around.
Okay.
There isn't a phrase for that. I think it's called something like dementia. But there's already a term for this sickness of AI models that were trained on too much artificial data.
Yeah. I think it's like a real cool thing when it comes to these diffusion models and this text to design. There was pretty just like I think a few weeks ago a video from Toyota Research who have done something similar on car design. And so to me personally, right now it feels that with these diffusion models, it's super nice and fancy, but right now I doubted that there might be something coming out of this which then can be really used in product design and let's say a bit downstream than the process chain. But I mean, who knows? So I would say the beginning of this has started, and yeah, I'm super curious to see how this evolves.
Maybe it's just
Alright,
me, but
guys.
I'm kind of. I'm sorry, Mark, please.
No. I feel very bad of I don't know, closing that discussion in about we have 6 more minutes to go. I would like to get your thoughts maybe on one little question, guys, and it's that you know, that future question coming ahead. So let's think it's 2033 ahead, and AI is somewhere in the future has developed further. You guys are all engineers, so I'm wondering, how do you expect your job to be different 10 years ahead on time from what you're doing right now? And then maybe also answering that question, what paradigms have shifted, or what do you expect to shift then really?
Yeah, I really expect that AI is really protocolling or monitoring how an engineer is working. So really monitoring how we drive cut, how we mesh, how we do this. So I really expect an AI which really takes a look on all my mouse clicks and everything and try to learn from that in 2030. And really maybe set up optimization and enhance it. This could be really a shift, a big shift. And
I do actually see it exactly the other way around. I would rather have an assistant who actually is like my personal autopilot who drives my mouse, and I just have to interfere when I think, no, actually I do want to make something different.
I also see AI as a recommendation tool. I think it's gonna be something that provides a range of options that maybe a human would not have come to. And then at the end of the day, as at least in 2030, I believe the humans still are gonna make the decision on which path to follow.
I really believe, like Benan, that it's going to be a co-pilot, and it's going to be a brutal co-pilot. A lot of people will lose their jobs or do different things. And I think we need to take it seriously, because I truly believe that companies who are still asking questions around the technology now will be totally disrupted. And that's what worries me the most, you know, especially here in our ecosystem. We ask a lot of questions, fair. We want to understand, we want to take time, and we don't take risks and go and start using it. I think tremendous changes from now a few years.
Yeah, it's like the self-driving cars currently. It's like makes most of the highway work, or just if you near a construction site or so, you have to intervene and take the wheel. But for engineers, could be that you get a task and the AI is preparing a lot of stuff, and you just wait to get the go signal. And this can really disrupt a lot. And that a lot of people will deliver data, will deliver workflows, will deliver how things are built up. And then a very few experts will do the driving and the design.
All right, thanks for that last comment, Benem. Thank you for all the great panelists. I think it was a very fruitful discussion, and I would love to have this to continue. Probably we'll do a second version of it, because I think there's just so much more to task and so much more to deep down to. I would like to close the session with two cool things KI Park is offering, and I will just shortly share my screen. So first announcement is, of course, that this is going to be recorded, and you can rewatch all the different like parts of the discussion once again. If it's online, we will keep you informed about that. And then you can probably see my screen right now, can't you?
Yeah.
Yes.
Okay, good. Then two more things that are coming up in next week. We are about to launch a new program, which is called the AI for Sustainability Connect program. What is it? Well, that's our goal to bringing about new AI innovation by connecting people in the ecosystem. What are we going to do about it? We are helping organizations to really use AI in terms of reaching sustainability goals or improving sustainability impacts of the organization. And we will really take them by the hand. At the first stage, it's going to be experts going deeply with you, defining what challenges do you have at the intersection of business impact, sustainable impact, and AI readiness. Then we're going to look for the right partners. We have experts scouting the industry for relevant startups or relevant partners and experts to join you and help you finding solutions towards the challenges. And then there will be a prototype development stage for 3 months, bringing you the real value and solving the challenges for you ahead. So it's a 6-month program to start, and that's going to be start this fall, this winter slash. And if you're interested in that, shoot me a message. I'm happy to give you some more information about it. And then the second really cool thing is which is going to pop up. It's we are expanding our network. We will soon launch a first satellite in Sweden, in Stockholm. And there's going to be a kickoff workshop. I think the date will be fixed today, or maybe tomorrow. It's going to be either the 8th or the 11th. And yeah, in that kickoff workshop, we just want to, bring KI Park a bit more prominent to Stockholm. There's going to be workshop. There's going to be events such as this one as well, being right up there. And if you like to contribute, if you're based in Stockholm, if you're based in Sweden somewhere, or have offices up there, shoot me a message, and we are going to host that workshop, because we're looking for partners to launching that satellite. We're doing it together with the German-Swedish Chamber of Commerce, and this is just going to be a very cool, exciting to be there at the start of that community and bring in your expertise. That being said, a lot of opportunities. Once again, thank you all for coming. If you like to get more information about KI Park, if you like to know about your events, this QR code here is guiding you towards my bento page. You can set a meeting with me directly. You can sign up for the newsletter. You can see the website. So it's all stored on that website. And yeah, I'm looking forward to seeing some of you back again during our next Tech Talk. It's going to take place in October. The date is, I think, the 19th or so. Already said, you will receive all the information if you're signing up for newsletters ahead. And yeah, thanks you again to the panelists for that discussion, and looking really forward to continuing the work on AI and seeing new paradigm shifts in AI and for engineering.
Thanks, Mark, for having us.
Thank you. Bye.
Bye.